As we come to the end of this course on Agentic AI, it's worth stepping back and looking at the journey we've been on. Throughout the past modules, we explored how modern AI systems move beyond simple prompting into full agentic behavior, systems that can reason, take actions, use tools, coordinate workflows, and continuously improve. We examined the architectural pieces that make this possible: models, tools, memory, context, local models, evals, observability, and fine-tuning. In this final video, we'll briefly summarize the key ideas we have covered, reflect on how all these components fit together, and look ahead at where the field is moving, and how agentic systems will continue to evolve. Throughout this course, we have traced the full arc of how modern agentic AI systems are built and improved. We began with LLMs as the core reasoning engine, the foundation on which everything else is constructed. From there, we moved to agents, exploring how models can be turned into systems that plan, act, and interact with their environments. We examined tools and MCP servers, which extend an agent's capabilities beyond text and allow it to operate inside real-world workflows. We looked at local models, adding the dimension of efficiency, privacy, and deployment flexibility. To ensure these systems behave reliably, we introduced evals and then observability, the layer that records what agents actually do so that evaluation and debugging become possible. And finally, we discussed model improvement techniques such as fine-tuning and distillation, which allow us to tailor models to specific domains, policies, and performance requirements. Looking at everything we have covered so far, it becomes clear that a substantial foundation for agentic AI systems has emerged recently in just a short period of time. We already have strong general-purpose LLMs that provide the core reasoning ability. We have rapidly maturing agent frameworks that give structure to planning and action-taking. We have an expanding ecosystem of tools and integrations that allow agents to interact with real systems. We have evaluation and observability practices that make agent behavior measurable and improvable. And we have model adaptation techniques like fine-tuning and distillation that let us shape models for specialized domains and real-world needs. Taken together, these components show that the groundwork is in place. It is strong and accelerating. The field has moved from experimentation toward engineering, and the pace of progress continues to rise. As strong as today's foundations are, we are still at the very beginning of the agentic AI era. Most applications we use today are still built in the traditional software paradigm, but the shift toward AI-native, agent-driven systems is clearly underway. In the coming years, we will see agents become more capable, more autonomous, and far more integrated into everyday software. Tool use will expand dramatically. Local models will become faster and cheaper. Evals and observability will mature into standard engineering practice, and a whole new generation of workflows, products, and even professions will be built around these capabilities. We're entering a phase where nearly every digital workflow can be reimagined, not just enhanced, but redesigned around AI reasoning, tool use, and adaptation. Thank you for joining this course on Agentic AI. I hope it has given you a clear initial understanding of how modern AI systems are built. It's an incredibly exciting time to be working in this field, and I'm looking forward to seeing what you'll be creating. If you'd like to stay in touch, continue the conversation, or share what you build, feel free to connect with me on LinkedIn. I'm always happy to hear from people in this space. Thank you again for your time and all the best on your journey with Agentic AI.